Imagine flaring over Narita's runway with gusts slamming the airspeed up and down. Then the thrust levers pull back at 50 feet. The nose hesitates, the jet slams, bounces, and the next input shoves 430,000 pounds straight into concrete. In 9 seconds, a routine landing becomes an upside-down fireball. This wasn't pilot error alone. It was a design quirk baked into a famous trijet, one that had already bitten this airline before. The altimeter whispers 50. Retard. Throttles slide back. The sink tightens. A hard thump. All 3 gear hit at once, and the MD-11 springs off the concrete before anyone can breathe. For a heartbeat, the cockpit rides a cushion of nothing, then a shove, nose nudging down to plant it, meets a hungry lull in the wind. Bang! The nose digs first. Mains smash after, spoilers snap, then stow as the jet ricochets higher than before. No power, no time. The trijet pitches, hesitates, and drops like a hammer. Crack. The left main gear folds, not cleanly, but up into the wing, fuel and metal tearing in the same instant. Fire blooms along the left side as drag yanks the aircraft off center line. The right wing still lifts, the left no longer can. The world rolls 90, 20, 180. The cockpit is suddenly upside down, alarms screaming, flame chasing the sliding fuselage into the dawn. From touchdown to inferno, 9 seconds. On screen, how a design quirk primed FedEx 80 for disaster. FedEx Flight 80 began like any other overnight cargo mission. A workhorse leg connecting Guangzhou, China, with Tokyo's Narita Airport. The aircraft, a converted MD-11 freighter, carried its load of packages across the South China Sea under a dark, pre-dawn sky. On board were 2 highly trained aviators, a seasoned captain with thousands of hours in both military jets and FedEx's trijets, and a first officer whose background included piloting massive U.S. Air Force C-5s, but with fewer hours on the MD-11. For them, this was supposed to be a routine end to a long night, yet the stakes were quietly building. Cargo operations often force crews to fly through the circadian low, when fatigue silently dulls reflexes and sharpness. As Narita's morning arrival rush intensified, the conditions waiting at the runway were far from ideal. Winds gusted above 30 knots, swinging violently between lulls and surges, the kind of environment where even a stable approach could turn unstable in seconds. In this setting, a heavy jet at the end of a fatiguing night, threading into a crowded arrival bank, the stage was set for a tragedy that would unfold in less time than it takes to draw a single breath. In the cockpit of FedEx Flight 80 sat 2 men who, on paper, were more than capable of handling the challenges ahead. In the left seat was the captain, a 54-year-old veteran who had begun his career flying fighters in the U.S. Marine Corps before transitioning to the world of commercial cargo. With more than 8,000 hours of total flight time, over 3,600 of them logged specifically on the MD-11, he was known among colleagues as methodical, steady, and by the book, the kind of pilot you wanted beside you when things got rough. Beside him sat the first officer, 49 years old, with a background flying the colossal C-5 Galaxy for the U.S. Air Force before joining FedEx. He had logged more than 5,000 hours overall, but only about 879 on the MD-11, leaving him less seasoned with this notoriously unforgiving jet. Though not a rookie, he was still building fluency with the aircraft's quirks. Like many cargo crews, both men were battling the invisible strain of overnight schedules that erode natural body rhythms. On the cockpit voice recorder, just 45 minutes before landing, the first officer casually admitted his fatigue and joked that if things got too quiet, they should make noise to keep each other awake. It was a lighthearted remark, but it underscored a truth every night freighter pilot knows. Fatigue doesn't just dull the body, it quietly clouds judgment. And on this morning, that would matter more than either man realized. As dawn broke over Tokyo, Narita's runways were already alive with a steady stream of passenger and cargo jets converging from across Asia, and controllers in the tower were working at a relentless pace. For FedEx Flight 80, the challenge wasn't traffic but the weather. Strong northwesterly winds swept across the airport, gusting past 30 knots and shifting violently between highs and lows. Moments before their arrival, another aircraft reported encountering wind shear, variations of nearly 15 knots in airspeed within just a few seconds, below 2,000 feet on approach. Air traffic control relayed the warning, followed by updated reports that made the picture even bleaker. Winds at 320 degrees. Steady near 26 knots, but spiking to 38 and dropping as low as 16, a spread of more than 20 knots. For a pilot, these swings meant constant corrections, crabbing into the crosswind one moment, chasing decaying airspeed the next, all while fighting turbulence stirred up by the terrain and airport structures below. None of it exceeded published limits, and countless flights had landed at Narita in worse. But in gusts this sharp, the definition of a stabilized approach becomes a matter of judgment, not numbers. On this morning, the wind problem wasn't just about strength, it was about unpredictability. And unpredictability is what quietly erodes the margin for error. The airplane carrying FedEx Flight 80 was no ordinary freighter. It was an MD-11, a jet with a reputation that divided pilots. Born as McDonnell Douglas's modernized successor to the DC-10, the MD-11 was stretched longer, fitted with more powerful engines, and updated with automation meant to make it efficient and competitive with Boeing and Airbus. But those promises came with compromises. To reduce drag and extend range, engineers shrank the horizontal stabilizer at the tail, altering the aircraft's natural balance and leaving it with what pilots often described as a barbell effect. Sluggish to pitch up or down at first, but hard to stop once the motion began. To counteract this, designers introduced the Longitudinal Stability Augmentation System, LSAS, a computer that helped dampen pitch changes and trim the jet in flight. On paper, it gave the MD-11 the stability of a bigger tail, but near the ground, its limits became obvious. LSAS could be overridden with just a few pounds of force on the yoke, leaving pilots fully exposed to the jet's quirks. Complicating matters further, the MD-11's cockpit sat unusually far ahead of the main landing gear, which distorted a pilot's sense of height in the flare, and its approach speeds ran higher than similar wide-bodies, demanding precision in gusty conditions. Even its auto-throttle system carried a hidden trap, programmed to begin reducing thrust at 50 feet as if the plane were performing an automated landing, bleeding off energy at the exact moment human pilots needed cushion the most. All of this gave the MD-11 a personality that was loved for its raw power, but feared for its unforgiving handling, especially during landings. In calm conditions, it behaved like any other heavy jet, but in turbulence or gusty winds, it demanded perfection and punished even small mistakes with devastating consequences. As FedEx Flight 80 descended into Narita's busy morning airspace, the crew worked through their checklists with the calm efficiency of men who had done this countless times before. The first officer, flying the approach, called out speeds and configurations as the captain monitored instruments and communications. Despite the gusting crosswinds and fluctuating airspeed, the jet was aligned with the glide slope, its descent rate within acceptable limits. At the key decision point, where crews must determine if an approach is stable or not, the captain made the call: stabilized. It was a declaration that, in that moment, the aircraft met the criteria to continue. But in truth, the picture wasn't perfectly clean. The airspeed needle was swinging beyond the usual plus 10-knot window, and minor deviations crept in with each gust. In textbook training, such variations would trigger a go-around, but in real-world operations, pilots often judge stability on averages rather than absolutes. After all, if every gust-induced fluctuation led to an aborted landing, flights in windy airports would rarely touch down. On this morning, both pilots believed the MD-11 was under control, its deviations manageable. What they couldn't see was how those small fluctuations, accepted in the name of practicality, were already eroding the safety margin, setting up a chain of events where the line between stable and unstable would blur fatally fast. Crossing into the final minute of flight, FedEx 80 was lined up with runway 34L, but the winds were playing their cruel game. At 200 feet, the MD-11 was still carrying excess energy, racing in at nearly 178 knots, well above its target landing speed of 164. Seconds later, a sharp lull in the gusts robbed the jet of airspeed, dropping it to just 154 knots by the time it neared the flare window. The swing was violent, more than 20 knots gone in moments, and the auto throttle, already locked into its pre-programmed retard mode at 50 feet, was too slow to respond. Instead of cushioning the descent, the engines continued to spool back, bleeding away the very buffer the pilots would soon need. The first officer focused on riding the turbulent glide path, waited too long to initiate the flare, delaying until about 20 feet instead of 30, and when he finally pulled, the big trijet's inertia made it feel unresponsive. In those tense seconds, his instinct was to pull harder, then correct forward, a subtle but dangerous dance of overcorrections that would soon send the airplane into its first punishing impact. What looked stable from the control tower was inside the cockpit, already unraveling, a jet oscillating between too fast and too slow, with its margin for error evaporating in the shifting winds. The MD-11 struck the runway with a bone-jarring thud, all three landing gears slamming down at once with forces recorded at over 1.6 G. In that instant, 430,000 pounds of aircraft and cargo rebounded violently, but from the pilot's perspective, up in the nose, positioned far ahead of the main landing gear, the sensation was deceiving. To them, it felt like the aircraft had planted firmly and was rolling out, when in reality the jet was already back in the air, riding an unseen bounce. The ground spoilers, triggered by the brief wait-on-wheels signal, had started to deploy, only to snap closed again as the sensors lost contact. Reverse thrust spools began and then abruptly canceled, leaving the aircraft in a dangerous in-between state, neither solidly on the ground nor truly flying. This hidden bounce was a known trap with the MD-11. The cockpit's distance from the main gear often robbed pilots of the cues that told them they were airborne again. Instead of recognizing the rebound, the first officer believed the landing had succeeded and prepared to derotate, not realizing that the jet was already climbing into the second act of a deadly sequence. As the MD-11 lifted back into the air from its hidden bounce, the first officer misread the situation. Believing the aircraft was firmly on the ground and waiting for the nose gear to settle, he pushed forward on the yoke to encourage derotation. But the jet wasn't rolling, it was still airborne, and that forward input drove the nose downward at exactly the wrong moment. Seconds later, the nose gear struck the runway first, slamming into the concrete with brutal force, followed by the main gear, which absorbed an impact more than twice their certified design limit. The shock reverberated through the airframe, bending metal, jarring systems, and briefly bottoming out the struts. This second strike hurled the MD-11 even higher into the air, vaulting it to nearly 16 feet above the surface, but with no thrust being added to recover. What should have been a moment to recognize the danger and execute a go-around instead became another step in a worsening chain. The aircraft was now damaged, destabilized, and teetering on the edge of structural failure, yet still trapped in the illusion of a landing gone wrong, rather than a crisis spiraling out of control. The MD-11, now briefly airborne again after its brutal second slam, reached nearly 16 feet above the runway, a fleeting chance to escape. A surge of power and a steady nose uphold could have broken the deadly cycle, perhaps even salvaged a battered but flyable aircraft. But that intervention never came. Neither pilot called for a go-around, and the throttles stayed idle as the first officer continued to fight the jet's pitch with out-of-sync control inputs. The nose dipped once more, momentum gathering, and the aircraft dropped like a hammer. The third impact was catastrophic. Over 3 G of force drove through the landing gear, shattering design limits. This time, the left main gear didn't shear away cleanly. Instead, it punched straight into the wing spar, rupturing the fuel tank in a spray of jet fuel. Sparks from grinding metal ignited an instant inferno as the crippled trijet veered violently, one wing still generating lift, while the other collapsed beneath it. Within seconds, the MD-11 rolled past 90 degrees and inverted, skidding upside down across the runway. The margin for recovery had vanished. The third strike was the point of no return. The third impact sealed the aircraft's fate. As the left main gear tore through the wing spar, fuel cascaded from the ruptured tank, igniting in a flash as metal scraped along the runway. Flames spread instantly down the left side of the MD-11, trailing the jet like a comet as it lurched violently off balance. With the left wing destroyed and dragging, the right wing still clawed at the air, twisting the freighter into a lethal roll. In mere seconds, the massive trijet flipped fully inverted, slamming upside down onto the runway with a screech of tearing metal and an eruption of fire. Now sliding on its roof, the aircraft became an inferno on momentum. jet fuel feeding flames that consumed the fuselage as it skidded to a halt in a plume of smoke and sparks. From the tower, controllers watched in horror as the orange glow expanded across the runway. Emergency crews, already scrambling at the first impact, rushed toward the wreckage, but the blaze was too fierce to penetrate. In less than half a minute, FedEx Flight 80 had gone from a routine landing to a fireball racing across Narita's concrete, leaving no chance for survival. In the aftermath, investigators combed through flight data and cockpit voice recordings to piece together the final moments of FedEx Flight 80. What they found was a chain of small but deadly missteps amplified by the MD-11's unforgiving design. The data showed that before both the first and second touchdowns, the first officer made significant nose-down control inputs. Inputs consistent with someone who believed the aircraft was firmly on the ground and trying to lower the nose wheel, when in fact the jet was still airborne. These inputs caused the nose gear to strike with excessive force, followed by the main gear absorbing impacts more than twice their certified design loads. The third slam exceeded 3G, leading to the catastrophic failure of the left landing gear and ultimately the wing spar. The cockpit voice recorder added a sobering human layer. No call for a go-around, no decisive takeover from the captain. Just small corrections and a belief that the situation was still recoverable until it wasn't. Investigators concluded that fatigue, fluctuating winds, and the captain's failure to intervene all played contributing roles. But the critical trigger remained those nose-down inputs at the worst possible moments. The data painted a clear picture. The accident was not the result of a single mistake, but the collapse of judgment, timing, and design margins in a matter of seconds. At the heart of FedEx Flight 80's tragedy was a design compromise that had haunted the MD-11 since its birth. To squeeze more efficiency out of a stretched DC-10 frame, McDonnell Douglas engineers reduced the size of the horizontal stabilizer, giving the jet less natural pitch stability. In theory, computerized systems like the Longitudinal Stability Augmentation System, LSAS, would smooth things out. But near the ground, those protections faded, leaving pilots to wrestle with an airplane that responded sluggishly at first, then snapped harder than expected once momentum built. Add to this the cockpit's location, positioned far ahead of the main landing gear, and pilots often misjudged their true position during landings, sometimes unaware the mains had bounced until it was too late. Finally, the auto-throttle logic designed for automated landings began pulling thrust back at 50 feet, even when the aircraft was hand-flown, often robbing pilots of vital cushion in gusty conditions. None of these quirks were unknown. They were documented and trained for, but together they created an airplane with razor-thin margins during rough landings, one that could turn a single mistimed input into a fatal cascade. In plain terms, the MD-11 was efficient in cruise, but in the flare it was a predator waiting for small mistakes. Beyond the quirks of the MD-11 itself, the investigation highlighted the human factors that quietly stacked the odds against FedEx Flight 80. Both pilots were operating at the tail end of a fatiguing overnight shift, flying into dawn, the body's natural low point, when alertness and reaction times are most compromised. The first officer, though experienced overall, had less than 900 hours on the MD-11, still short of the level of instinctive familiarity needed for a jet this unforgiving. When the aircraft bounced, his training should have guided him to hold the nose steady at about 7.5 degrees, add power, and go around if things grew unstable. But that lesson had only been covered once during simulator sessions years earlier and was not reinforced in recurrent training, leaving a critical skill underdeveloped. Meanwhile, the captain, more seasoned and by the book, never asserted control or called for a go-around, a lapse that investigators flagged as a breakdown in crew resource management. Fatigue, gaps in bounce recovery training, and hesitation in cockpit leadership didn't cause the accident on their own, but they ensured that when the MD-11 revealed its harshest tendencies, the crew had little left to counter them. FedEx Flight 80 was not the first time the MD-11 had punished small errors with catastrophic results. A decade earlier, in 1997, FedEx Flight 14 attempted to land at Newark, but touched down long and hard. The captain, eager to force the jet onto the runway, pushed the nose down after a bounce, triggering a violent slam that collapsed the gear and flipped the aircraft onto its back. In 1999, a China Airlines cargo MD-11 at Hong Kong fell victim to the same pattern. Firm touchdown. Rebound, nose-down correction, then a destructive second strike that tore the aircraft apart. And in 2010, just a year after Narita, a Lufthansa cargo MD-11 in Riyadh was lost in almost identical fashion. Each case followed the same deadly rhythm: an initial bounce, a misinterpreted sense of being on the ground, a nose-down input, and then structural overload on the second or third impact. By the mid-2000s, the MD-11 had accumulated one of the highest hull loss rates of any modern widebody, with a reputation among pilots as a jet that demanded near-perfect landings. FedEx 80's crash was not an anomaly. It was the latest entry in a grim pattern that revealed the MD-11's design flaws and the razor-thin margin it allowed when anything went wrong close to the runway. One of the most haunting questions from FedEx. Flight 80 is why a go-around was never called. In training, the rule is simple. If the approach becomes unstable, you climb away and try again. But in the real world of gusty, high-wind landings, the definition of unstable often blurs. On final that morning, the MD-11 was swinging through airspeed excursions, but on average, it still looked acceptable. On glide slope, on centerline, and under apparent control. Both pilots likely believed they could ride out the turbulence just as countless flights before them had done. Complicating matters, the first officer was still flying, and the captain, though more experienced, never took over or called my controls. In that fleeting window, cognitive bias and operational mindset worked against them. They were committed to landing, and the deviations felt like they were within the envelope. The cruel irony is that the safest choice, to add power and climb away, was available until the very last seconds, but by the time the need became undeniable, the MD-11 was already locked into the bounce cascade that no go-around could undo. In the wake of FedEx Flight 80 and other similar MD-11 accidents, the aviation industry took hard lessons to heart. Airlines operating the type placed renewed emphasis on bounce recognition and recovery, ensuring pilots practiced these scenarios not just once in initial training, but repeatedly during recurrent simulator sessions. Standard operating procedures were refined to address the MD-11's quirks more directly, including clearer criteria for when to abandon an approach in gusty conditions and more explicit guidance on how and when to disconnect the auto throttle during manual landings. Some operators even adapted monitored approach concepts, allowing captains to take control during the riskiest phases if conditions deteriorated. Regulators, meanwhile, pushed for stronger training in fatigue management and decision-making under stress, recognizing how often overnight cargo schedules put crews at their physiological limits. None of these changes could undo the tragedy at Narita, but they narrowed the gaps, ensuring that future MD-11 pilots and the industry as a whole would be better prepared to stop a deadly bounce cascade before it ever began. The crash of FedEx Flight 80 reinforced a truth long whispered among pilots. The MD-11 was not a bad airplane, but it was an unforgiving one. In cruise, it was efficient, powerful, and reliable. But in the final seconds of a landing, it demanded precision few other jets required. The myth that these accidents were simply pilot error ignores the reality. Design compromises, fatigue, and limited training created a razor-thin margin for mistakes. The takeaway is not that the MD-11 was doomed, but that safety in aviation depends on respecting those margins, recognizing when stability is slipping, executing a go-around without hesitation, and ensuring training prepares crews for the quirks of the machines they fly. FedEx 80's legacy is a sobering reminder that disasters rarely come from a single mistake. They come when design flaws, human factors, and split-second misjudgments collide. From the first touchdown to the final inferno, only 9 seconds passed, 9 heartbeats in which a routine landing unraveled into disaster. In that brief span, the MD-11's hidden quirks, the crew's fatigue, and the unforgiving winds converged to erase every margin of safety. FedEx Flight 80 is remembered not just for the loss of 2 skilled aviators, but for the lessons it carved into aviation. Respect the limits of stability. Never hesitate to go around, and understand the machine you fly in its most unforgiving moments. 9 seconds may seem insignificant, but in aviation, it can mean the difference between a safe landing and catastrophe. And that is the legacy of this flight, a reminder that every decision, every input, and every ounce of awareness counts when the runway is rushing up to meet you.